Good afternoon, ladies and gentlemen, and welcome to our first technical presentation for the year. From the Southern African Coal Processing Society, we'd like to wish you all a happy new year and hope that it is a blessed one for yourselves and your family. Thank you very much for joining us today. I would also like to say thank you very much to James Agenbag, who will be presenting in this forum for us today. I think if I can do a quick introduction on James and a little bit on his history. James will then take over and do his presentation. There is a question and answer tab. So should you have any questions, please type your question and I will get all the questions and we can direct those to James at the end of his presentation. So yeah, to get to the main event, I think let me introduce James first. So James has been in our industry for 18 years, covering process design, commissioning and optimization of processing facilities across multiple commodities. In 2008, James moved to Australia to help build DRA's Brisbane office. After he spent 3 years responsible for the process engineering discipline across Peabody's coal projects, he has experienced firsthand the differences between Australian and South Africa on how Australians and South Africans think about coal processing, trying to apply his passion for fine mineral beneficiation into both industries. James was part of a startup called Cape Coal that launched Bowen Coking Coal in 2017, the only pure coking coal player listed on the Australian Stock Exchange. He served on the board of this $40 million company until very recently. And today, James's presentation is titled Why Australians and South Africans Wash Coal Differently. So I'm really looking forward to this presentation. James, over to you. Thank you very much.
Thank you, Jason. Yeah, I thought we celebrated Australia Day with our Australian friends on Tuesday. So I thought it would be fitting to try and weave a bit of Australian history into the first South African Coal Prep Society discussion this year. Australia Day, for those of you who don't know, marks the anniversary of the first fleet of 11 ships carrying British convicts to the colony of what was then called New South Wales back in 1788. Now, by 1788, us South Africans already long had our own criminal gangs operating in the Cape of Good Hope. So we are at least 100 years ahead of them. This discussion, and I really would have liked for this to have been an active discussion. It would have been nice if we could have been together and you guys could have asked questions and added to what I have to say. But this discussion has been titled Industry Evolution, Why Australians and South Africans Wash Coal Differently. And I'm sure many of you have, as much as I have over the years, been in a conference on both sides of the Indian Ocean where you've experienced some form of heated debate and I must say mostly gentlemanly disagreements between sets of people who we hold in very high regard, some of them present today and some listening from heaven, about who is right and who's wrong when it comes to the washing of coal. Favorite topics I'm sure you're familiar with included things like near gravity content and whether that's important or not important, breakaway size, the use of non-standard DMS cyclone dimensions, how we should measure magnetite consumption, and many more. But today is really not about proving who's wrong and who's right, and nor is it about which is better and which is best. All I want to do today is try and point out some of the reasons the two are different. And so I trust, Jason, that it's moved on to the next slide. Can I just check that it does?
Yes, James, it has moved on to the next slide. You can continue.
Okay, good. So if you're not one of the many Australians that have either already moved to Australia or is planning to move to Australia, then you're probably in the other part of South Africans that generally don't have much affinity towards Australians at all. And so if you're in that latter category, I've included this map of what was then the known world back in 1599. And as you can see from this world map, Australia didn't even make it on the map by that time. So don't stress about the Australians too much. Haven't been around that long. So if you can imagine Australia over here and South Africa, you know where that is. My family and I have managed to strategically position ourselves as close to halfway between Australia and South Africa as one could possibly be, unless you lived on a boat. So you can safely say I'm sitting on the fence nowadays, and so I think it's appropriate that I could present to you the differences between these two industries. So, by the way, just if it's important to you, Mauritius certainly was on the map already by 1502. So I'm just saying to the Aussies. Okay, so really my view is that much with every other kind of evolution, it's mainly the environmental drivers that dictate how things evolve differently. And so I think there's these two pictures of, you know, one at the bottom is an animal that we love in South Africa, and the one at the top is the one that the Aussies love unless they are driving at night. These two animals almost, you know, when they're up in the air like this, there's a similarity between the two. And they've evolved differently because they've evolved in different places and they've had a different set of environmental drivers behind their evolution. And so similarly, I think our two industries have developed their own little nuances. And it's all because of the different drivers. And the drivers include, and some of the topics I want to discuss today, they include, of course, the differences in our coal characteristics. So there's a vast difference between the typical Witbank 2-seam and 4-seam coal ore bodies that South Africa's coal industry was built on, and let's call it the you know, that nice thick Goonyella middle seams of the Australian coking coal fields in Queensland, or even the Wrangell's coals. Our two countries historically, more so I think than today, have had a very big difference in the labor cost structure, and so that's a big environmental driver. Scale is another one. I always tell my Australian friends that one of the big differences between mining in Africa and mining in Australia is in Africa you get a lot of smaller entities mining, whilst in Australia it's really rare to see a small entity mining. So normally people do things at scale. So plants are normally, you know, 5, 6, 7, 800,000 ton an hour, 2,000 ton an hour plants. Whilst in South African industry, I think you get quite a few 250, 350, 450 ton an hour plants. That's a difference. There's a difference, I think, and I'm keen to hear your views on this. I'm not too close to vendor support in South Africa, but I think there's a difference I picked up when I moved to Australia between the way equipment vendors are set up in terms of providing maintenance and operating support to the coal industry. And then, of course, there's a difference in the sets of regulation, which specifically we'll talk about it, but it specifically has to do with tailings disposal and also safety. Okay, so if we tackle the biggest one, I think, and the most interesting one for me, but one that'll probably take me too long to cover in detail, it's really the differences in our coal characteristics. And yeah, I hope I've just grabbed a couple of washabilities that I could find from my database. It might not be representative of the industry as a whole, but in general, I think if we look at the mass percent present, as opposed to the density fractions on the x-axis, what we typically call a washability. In the South African coals, we definitely have a lot more material in the sort of what we call near gravity zone, in the areas in and around where we're trying to separate. So there's a lot of coal in this density zone between 1.45 and 1.65. And if you look at the Australian coals, typically, historically especially, there's almost nothing in that density fraction. So they either have very low ash, high quality coal, low density coal on the left, or really high ash, almost no carbon reject on the right. So that, of course, is a huge difference. So what are the things that difference drives? I think the biggest aspect is probably that when you have a lot of material in the near gravity zone, you have to be really careful about your separation efficiency. And so I think that is what drove the South African coal industry to stick for a long time to small, dense, medium cyclones. Sometimes we even did split washers, where we try and keep the cyclone size small, but split the mass into two size fractions to try and keep that separation density as close to the ideal separation density as possible. And we also stuck in South Africa to the standard DSM cyclone dimensions, which I think is all necessary because of how important the separation efficiency is when you are separating so close to an area with high mass. So when you compare that to Australia, for instance, Australia typically goes for non-standard, non-DSM cyclone dimensions, and much bigger cyclones. They go up to 1150, 1300, even 1500 mil diameter cyclones now. And really, for them, it's no issue because they don't need to mind much because there's nothing in this near density zone. Okay, let me think about what other things this near gravity aspect changes. I suppose it means that the feed ash is typically already quite low in Australian coals, whilst in South African coals the feed ash is already start off quite high. We've both been blessed, both industries been blessed with fairly thick seams, which is nice. If we just look at some of the other characteristics, South African coal tends to be much more abrasive than Australian coal. So that's something I had to learn. Obviously knew nothing about coking coal when I got to Australia, and they have this thing called hard coking coal. So it turns out hard coking coal is not hard at all. It's actually really soft. So I think the term hard refers to the coke strength after they've turned it into coke. But coking coal in Australia is very friable. You almost look at it and it breaks. If you hold it in your hand and you just break it like it's nothing. And so also not very abrasive. And so that aspect has led to a number of differences in our industry. So because South Africa's coal is so abrasive and we've got really hard, competent material in between, these Avon style crushers with the self-relieving mechanism have been very popular. Whilst in Australia, they use these fixed center, what they call mineral sizes, typically, or these feeder breaker type arrangements. So there's another big thing that the abrasivity has driven, big difference. You guys would know in the South African industry, in our D-slime screens, or gosh, I don't even know whether do you guys call it D-slime or feed prep? Anyways, doesn't matter. So your feed prep screen and your drain and rinse screen apertures in South Africa, typically those multi-textile polyurethane panels. And so you don't see any of that almost in Australia. So in Australia, the screen panels are almost all wedge wire, stainless steel wedge wire panels. And I think one of the reasons we don't do that very widely in South Africa is probably because of the abrasivity of our coal. So it's possible that those polyurethane panels last longer than the wedge wire panels. So yeah, that's an interesting difference. The other difference is clay content. So that's one area where South Africa is blessed. I don't think the Witbank seams have much in terms of clay content. Some of this Australian coal has more clay than coal sometimes. You know, west of Brisbane, for instance, those coal fields around Ipswich and even further west. Sometimes I wondered when I went onto site whether it was in fact a coal mine or a bentonite clay mine, because many times I felt like the guys were mining more clay than coal. So the clay makes a difference in some of the ways they operate things. Some of these feeder breaker type arrangements and fixed center crushers run wet because of all the clay. We don't have those problems, I think, in most places in South Africa. And also, because of the clay content, the Australians typically don't recycle their MagSep effluent back to the screens. So it all goes to the D-slime screen. Now that's one other difference. And to cater for the clay content, they also have some nuances and differences in their plate work and their liner designs to avoid hang up. So there's some really clever chute designs that have come out of Australia. I know the South African industry has also improved its chute design a lot over the last 10 years or so. The other thing is in Australian coals, especially on the coking coal side, they typically target a product quality of between 8 and 10% ash. The ash content and specifically the calorific value is not important at all in coking coal, as most of you know. But in thermal coal, we have a very specific penalty or spec on calorific value. And so if in South Africa, we typically export 14% ash, that's our target. But we also have to be careful about things like moisture specs and material handleability. And so that's driven some differences in our industry. You know, in Australia, moisture is none of the mines that I was ever across ever had an issue on moisture, on product moisture. In fact, on some of the mines, we would put some hose pipes in the train wagons to increase the mass because we were not near our moisture penalty. So we could actually sell water for the price of coking coal, which was nice. So yeah, the difference in moisture spec, I think, has driven some of the South African designs. So I think you guys in South Africa are very careful about how you size. You're focused on generating less fines because the more fines you generate, the more moisture you eventually end up with in your product. And that net as received calorific value pricing drives this need for a reduced moisture. So I know also some of the plants in South Africa tend to wash at much larger sizes, like 100 ml in things like True Boys or other devices, and then they crush only after they've separated, again in an effort to minimize the fines generation and the final moisture content. So those are some differences. The other big difference that I wanted to cover briefly was just in how we size in South Africa. Typically in our feed prep screen, we size at 0.5 mil, whilst in Australia the standard size is 1.4 millimeters. So their aperture sizes are 3 times bigger than the South African aperture sizes. And that obviously leads to the potential for much bigger capacities in their, both in their feed prep screen, but more so in their drain and rinse screens. So if you can imagine, if you've got 3 times the aperture size, your screening increases dramatically. And the reason they can do that in Australia is because, again, they don't have all that near gravity. So they're able to still make a on-spec product in their spiral circuit, for instance, even when the spirals handle everything from 1.4 down. Whilst in the South African environment, because of all the near gravity, and also maybe because of the spiral technology that's been prevalent and available, you've had to be very careful to push as little as possible material to the fine circuit. And so you send all the plus 0.5 millimeter to the dense medium cyclone, because it's still going to do a better job than the fine circuit. So that's a big difference. All right, let's just briefly cover, Jason's given me 20 or 25 minutes. Let's briefly cover the other aspects. So a big aspect historically, especially, has been the cost of labor. You guys would have heard from people that, to pay guys to do a job on the road or something in Australia is very expensive. The postman earns more or less the same as the process engineer. So it's been a big focus in Australia to minimize the labor requirement. And so if you take this picture, for example, on the left, you've got a South African application, very similar to the one on the right. And I think I counted about 22 South Africans on that job compared to 5 Aussies. And so that is sort of a typical thing in Australia. And so you'll see normally there's about 4 people operating in a shift in a cold prep plant in Australia. And so to make that work, their designs have had to cater for ease of maintenance. They've got crawl beams above all their equipment. It's very easy and spacious and much more comfortable to work in an Australian prep plant. So that's been a big driver. There's a bunch of other things that, for instance, concrete costs. A lot of the South African designs focus on minimizing the use of concrete because every cube of concrete costs money. But in Australia, they tend to not minimize the volume of concrete because concrete is relatively cheap. What is expensive in Australia is things like formwork. So if you need labor to do the formwork to make the shapes of the concrete, that ends up costing more than the actual concrete itself. So typically they'd rather have big, flat, simple floors all filled with concrete rather than little nooks and bends and areas that require a lot of formwork. So that's just a typical difference that the cost of labor can drive. And similar to concrete, steel structures is also something that's impacted directly by the cost of labor. So this is probably not the best picture in the middle here, but if you think of a South African plant historically, especially, you see thin steel work sections. The focus on these plants are typically, especially because you have low capacity plants like 300 or 400 ton an hour plants, capital cost becomes very important. So what the engineers have done in South Africa, they've become very clever at designing structures that are very light. So the overall steel mass is low, but it means you have a whole lot of braces and little pieces that you have to bolt together eventually. And so compare that to Australia, where you've got these bulky sections. And you can see this plant on the top left here. I don't know if you can see clearly, but they virtually have no bracing. It's just square sections that's actually lifted in, pre-assembled most of the time. And the reason is it takes too much time for people to put those pieces together, and the cost of the people is so expensive that it's actually more expensive than the additional weight in the steel. So you end up with these really nice, clean looking plants, again, driven by that cost of labor. And then we spoke in the beginning a little bit about scale. I don't think I need to say much more about that. You can see a guy here in front of one of these mammoth dense medium cyclones. It's very common there. Large screens, probably similar to what we see at Paula and Douglas and those type of places. But because the scale of their plants are so big, the overall project financials become much less sensitive to the capital cost. And so capital cost hasn't been the biggest driver in the design of their plants. Operating costs actually is a much bigger driver. Then I spoke briefly, but this is something that struck me when I first arrived in Australia. In an Australian prep plant, because you've only got maybe 4 guys on site in a shift, you don't have people maintaining pumps or changing screen panels or anything like that. These 4 guys are there to make sure the plant operates efficiently. And by the way, that includes the management. And so what you do have in Australia, you've got these centers of equipment manufacturers like Weir or Warman on the pump side, and on the left there's a picture here of a Mezzo guy that's in charge of, maybe it was also pumps or screens or something. Similarly, the screen suppliers have contracts on a dollar per ton basis to maintain the screen decks. And so you have these really qualified, really specialized maintenance teams that come in on a regular basis. They have a standing contract. They don't have to have a purchase order for every job. They just come in and they, quickly knock out what needs to be knocked out. But a very specialized, very well-trained service that I think has driven some innovation on the Australian side. And so typically the result of all this is typically an Australian prep plant will get more than 7,200 hours a year of actual running hours on coal, compared to, I don't know what we get in South Africa now, but probably around 6,800 on average or something, which is still better than places like Indonesia, which probably does just over 6,000 hours a year. But so vendor support has been is a big environmental driver. And then the last one, before Jason kicks me off, is just regulation. And so I won't talk about it a lot, but safety is a major thing in the Australian industry as a whole. The mining industry is no exception. So designs have a lot of emphasis on safety. So that's one aspect. And then the regulation on tailings disposal. In Australia right now, I think it's almost impossible to get approval for a tailings facility. So most of their tailings disposal is going dry. But in contrast to what we've done very successfully in South Africa with these belt press filters, and I'm sure Jason can tell us all about those. In Australia, if you say the word belt press or plate and frame filter to someone in the coal industry, they want to shoot you. And I was a bit unsettled by that in the beginning, but they've had some bad experiences, partially because probably of the large clay content in some of their coals, but they don't, for some reason, they don't like plate and frame filters. They tend to go with many of these little complicated looking Phoenix belt press filters. So it's either this or these co-disposal facilities, which actually looks quite neat, where they dispose of their coarse reject along with their fine reject all in one facility. So yeah, that's just in contrast to maybe a lot of fine tailings dams in South African industry and the plate and frame filters. So to sum up, I think there's a lot of opportunity and diversity. And the example I want to use is because we have different mindsets as South Africans and Australians, what we should try and do is understand why we have those different mindsets, understand which experiences have driven those differences in thinking, and then leverage that. And an example of that is 4 other South Africans and I were in Brisbane, and we looked around us and we said, well, these Aussies are so lucky with some of the coals they have. They're just so blessed with how easy they have it. And with our South African mindset, we started a little entity, and we just looked at coals that were not as flash as what the Aussies were used to. And so we found some opportunities where we could apply our South African thinking and experience in the Australian industry. And that's turned out to be a very successful venture. So I invite all the questions. I'm looking forward to answering as many as I can.
James, thank you very much for that very interesting and very insightful presentation. I think just imagine an audience standing up and giving you applause, because I'm sure that's what the guys are doing at home or in their offices or wherever they're bound at the moment. Just to go straight to a couple of comments. There's a couple of comments and one question that has come through thus far. The comments from Ores Trillion. Interesting and unbiased view. Thank you for the presentation. Both countries have advanced coal processing significantly, and each other could still learn from each other. Then Ores Trillion also, what are some of the major challenges faced by Australian and South African coal processing plants currently? Can you please address that question?
Some of the major challenges of Australian plants. I think there's a short-term problem in Australia, of course, with the Chinese not wanting to buy their coal. But I think generally the issues with Australian coal plants, I suppose, is their resources are diminishing in the sense that their premium resources are now almost nowhere to be found, and so they are constantly, looking at extracting value from resources that are much more South African in its nature or in its look and feel than what they've been used to. And so I think the Australian industry is at a benefit there because they have the ability to leverage on some of the South Africans' knowledge and experience to try and solve some of the issues they have. In South Africa, I'm not sure what your guys' challenges are, actually. I'll be keen to hear from the audience, but maybe you've done with the Guptas now. I suppose Eskom has stopped buying rocks. What are the issues facing South Africa?
Okay, James, I think we'll leave that question there. Another question, what prevents the South African plants from running with only 4 or 5 people?
That's a good question. I think maybe not that much. The part of the issue, I think, in South Africa is we want to try and create jobs. So there's a big driver in our society to want to actually add jobs. And so it might be that we can run on 4 people, but maybe that's not what the situation needs. I think giving people jobs is probably a necessary thing in the South African space. But if you think of things that the Aussies do typically in their centrifuges and their pumps and things that cause breakdowns and cause people hassle and time on site. They do regular full unit change outs. So for instance, the pump vendors will bring an entire pump and just swap the whole thing out. They won't mess around by trying to pull out impellers or fix glands or anything. They just pull the whole thing off, put a new pump in, and then they take it to the nearby central facility and service it where they've got time.
Okay, thank you very much, James. I think moving on to the next from Dr. T. Gauricharan. Can you elaborate a little bit on the processing of coal fines in both countries? Yeah,
it's my favorite topic, so I don't know how much time we've got. In Australia, of course, they have a lot of flotation in the coking coal space and also in some of their thermal coal applications. So, I mean, that's a difference. It's only maybe one or two places I know of in South Africa that apply flotation. So that's one big difference. In South Africa, I think you guys throw away everything minus 150 micron somewhere out there, you tend to think, even though there's a lot of much coarser coal on your tailings dams. Fine processing, Australia has had this is who I work for, I suppose, but they've had a different technology of spirals available to them over the years. In South Africa, we have the Multitech spirals predominantly. So there are slight nuances between those two. The Australian one is slightly better at recovering fine coal, and it can separate at slightly lower densities. And so that helps them. And what has not helped them, or what's different there, is in Australia, you've got, especially on the fine coal processing side, you've got very good oversized protection. So even though the apertures are larger, it's 1.4 millimeters, they've got very, very good oversized protection. So their sumps are typically tall and skinny, and they all have protection on the top to prevent oversize from getting in. And so they can tune their fine circuits much more finely in Australia. And the equipment has developed in a way which allows finer separation, but it doesn't need to cater for, let's say, 20 mil particles or something that every now and then slips in. Whilst in the South African space, I find a lot of the fine circuits don't have such good oversized protection. And so the spiral technology that's developed in South Africa cater for that. And so you can have a big 20 mil particle pass through the spiral circuit, apparently at no harm, but the downside is that your efficiencies of separation are compromised.
Okay, thank you very much. Thanks, James. A question for Mark Creswell. Are there any discard reclaim plants in Australia?
Yes, there are. There are. It's something I looked at extensively while I was there. There's a couple in New South Wales, some really old plants that they've started to recover very successfully. I think things like the area where the discard reclaim becomes attractive in Australia is because of the high value of the coking coal. So if you can do it before the coking coal has lost its coking properties, then there's a real value in it. But in Australian space, they've got used to the Jamison flotation cells, which is essentially just a flash flotation cell, very short resonance time, does not catch all the available carbon at all. And so there's a lot of high value, low ash coal on the Australian tailings dams for sure, but not so much in the core circuit.
Right. Thank you, James. Next question, Mr. Wasim Patel. What areas of coal processing in Australia would you say requires more optimization or improvement?
I think their flotation circuits, I just spoke about it now. I think they still lose a lot of coal in their flotation circuits in Australia. So what you see now slowly is you see plants adding additional flotation technology at the back end of their jammers and cells to try and capture some more. That's one thing. They're trying to focus in Australia on automation. So a lot of the Australian, big Australian entities like BHP and Rio Tinto, they've got their centralized operating rooms in Brisbane or Perth. And so for them, they're trying to run it all from a metallurgical point of view remotely. So there's a lot of focus right now in automating installation of cameras all over the show and instrumentation to try and run the plant without being there.
Okay. James, moving on to the next question. I think we'll start wrapping up in terms of questions now. We're running a little bit short on time. But the next question from Mr. Poita Mashaba. How does Australia deal with coal fine oxidation? Does oxidation affect the efficiency of froth flotation?
It does, I suppose. It does. So, yeah, I mean, most of the coking, well, a lot of the coking coal is underground mining, so they don't really have much problem with oxidation there. There are certainly areas where oxidation is a problem. They tend to stockpile it and run it through as a blend to try and minimize the impact on the plant setup. Yeah, oxidation is certainly a problem, but we don't have the issue in Australia that South Africa has of spontaneous combustion. I suppose that's a different question, but there seems to be forever smoke coming out of those piles in Witbank and South Africa. Australia doesn't really have those issues. But oxidation is a problem for some of the shallower mines, I suppose. Jason, I think you're on mute if you want to say something. If you guys can hear me, my issue is I can't hear anybody. I can only hear Jason, and right now he's on mute.
Hi, James. Sorry, I was just sorting out a technical issue there. But we've got another question from Professor Rosemary Falcon. South Africa has learned to use our higher density coals to replace coke in some of the met plants. Has Australia started to go down that route yet, given that their hard coking coals are being mined out?
I don't know how to answer that one diplomatically, but Australia has done their best to try and kill their steel industry. So I don't know if there's much steel making going on in Australia at the moment anymore. So in terms of replacing, you know, what they obviously have become very good at in Australia is the pulverized coal injection, or PCI coal, which is, you know, hasn't got the coking properties, but it's got the low ash and calorific value.
Okay, James, and then sorry, James, you can continue.
Sorry, there was a truck or something that went through my head, I think.
Sorry.
So yeah, I mean, in terms of marketing their higher density coals, they use that PCI. It's a big market in Australia. They use that as a coke replacement, I suppose, in the Japanese and the South Korean smelters.
Okay, great. I think, James, one comment from Henny Engelbrecht. Thank you, James. Quite informative and insightful. Appreciate. Then I think let's do the last question for today from Gerard Duplessis. What technology is used for flotation concentrate dewatering? Also belt presses? Are they also using solid bowl centrifuges?
Oh, that's a nice question. And it's nice to hear that Henny listened. Henny, nice to at least know that you're on. Gerrit, so they have historically used horizontal belt filters for the concentrate dewatering. And then long time ago now, they basically switched their technology of preference from belt filters, which are bulky and expensive from a capital point of view, to screen bowl centrifuges. So I think that's something we don't see in the South African industry. The screen bowl centrifuges, I think they lose about 50% of the minus 45 micron concentrate. They lose that to the water circuit. And so now the centrifuges are very good in terms of making a reasonably low moisture product in a very small footprint and sort of affordable capital cost. But the issue is that the amount of high value coal that those centrifuges, screen bowl centrifuges, still lose to the effluent. And so what you're seeing slowly but surely now in Australia is the introduction of solid bowl centrifuges, as you said there, taking that effluent from the screen bowl centrifuges and trying to capture the 10 tons an hour or whatever of solids from those circuits. So screen bowl centrifuges is all over the show in Australia for that flotation concentrate. Okay,
excellent. James, thank you very much. I think on behalf of everyone who listened in today and on behalf of the society, I would like to thank you. There will be a gift that will be sent to you as a token of our appreciation. It was really insightful today. And I think just everybody to wrap up today's session. Thanks for logging in. Our next technical meeting will be on the 25th of March, but Gerda will inform you prior to the date, the topic and the speaker. And we really look forward to you guys logging in again. But until then, please stay safe, look after one another, and looking forward to interacting with you on the 25th of March. Keep well.